Okay. Sorry guys, there was some issue with my Google Drive, so I could not send you the last time's recording link. I'm actually uploading it on YouTube and sending it to you. Yeah. So today we will be learning about some Python libraries that make machine learning in Python very, very easy. And they are the reason that Python is very, very famous for machine learning. Like they're one of the most important reasons why Python is famous for machine learning. Okay. So once, okay, I'll share my screen. When you can see my screen, just tell me. Can you see my screen?
Yeah.
Cool. Just so we'll be again using my very own. Can you see my screen? Cool. Yeah. Just create a new notebook. Cool. So one such library is called NumPy, and we use NumPy something like this. So import NumPy as NP. NumPy is used in a lot of other libraries also, like sklearn and all internally. So it's always advised or beneficial to use NumPy like NP. Okay. So what NumPy can do is the basic data structure of NumPy is an ND array. Remember, it is an ND array or an n-dimensional array. And one of the difference between NumPy and a normal list is that NumPy can only have values of the same type. So if I make a list like 1, 2, 3, 1, 2, 3, and Yuvraj, and if I try to make a NumPy array from this, it will throw an error. That string object cannot be interpreted as an integer because it saw that 1 to 3 are strings. It is integers, it wants something else as an integer as well. And it works now. So if you print type of n, you can see this is a NumPy ND array. This is the basic data structure of NumPy and NumPy. It's called an ND array. So you can create a NumPy ND array something like this. So let's create an array NP dot. Let's create an array of random numbers. Random dot random integers, and you can give the shape. So let's create 2 cross 2. Sorry, it's random. And if you see, now A is the array of random integers, in this case float values. You can create B and you can see. So what NumPy allows us to do is operate with these matrices or vectors very easily. So what you can do is, so you can create an array of ones. This is a This is a NumPy ND array where all elements are 1. And you can create one more array of ones. And what NumPy allows you to do is this. So if you do a plus b, it will add element by element. If you do a minus b, it will subtract element by element. You do a into p, it will multiply element by element. You do a by b till that it will not be defined. You can do a double by b and it will be an integer. You can do a power b and stuff like that. So NumPy array allows you to do element by element addition or subtraction. Okay, is this clear? Any questions? Anything that you do not understand till now? Yes, no, maybe. A was 1, B was 1, A into A has all elements 1, B has all elements 1. When you multiply these two, all the elements come out to be 1. Abhinay, NumPy is used for very fast mathematical calculations. No. See, B is also included once. This is the shape. If let me print A and B here. See, both are 1. Okay, the main use of NumPy is in internal coding of all the machine learning and AI algorithms. All the machine learning and AI algorithms are actually vector or vector mathematics. So we use NumPy for all the vector mathematics and vector applications. And it is used to do fast computations as well. I'll show you an example of fast computation. Anyhow, so you can define NumPy, like you can define a list and convert it to an NumPy array. You can do so you can do a lot of things. You can do numpy.add. Sum, and we'll give you sum of all the some issue is there. It's giving a random sum for some reason. Okay, wait, do it like this. Yeah. Okay, this is a weird behavior. Let's investigate why this is happening. Yes, if you write the 3D array will be created. This is a weird behavior. See, these are all the functions that you can do with NumPy. NumPy, you can use complex number, you can divide, dot will give you the dot product or the matrix multiplication. So I am trying to do a numpy.sum, right? Let's see why it's not working. Wait, let us check. Let's put n also. Okay, sorry, n is defined again and again. Oh, okay. So what really happened is it defined an array of size this instead of element this. So what we have to do is numpy convert list to array. As array is the function. Now it is correct. And numpy.nd array will create a random array of the size that you will specify here. Yes, it will create a 60 random array. Understand this? So you can do a lot of stuff with numpy. Let's define p as numpy.nd array 2 cross 2 d type. You can define d type. I'm not wrong, this works. Yeah. Okay, this is very long. Let's just divide p by, and this will also work. Watch. Anyhow, you can just simply have divided by 1. Yeah, and you can have q as so you can do a matrix multiplication using this. This will be the matrix multiplication of these two. To check, you have something called as ones. Sorry, identity. If you remember identity matrix from your class 12th, it is a matrix like this. All the diagonal elements are 1, rest of the elements are 0. And multiplying anything with the identity matrix is the same. You can say this is same as, so what happens is when you do a p dot q, the result is this. But when you do a p dot identity, the result is same as it was earlier. So you can see that this works. Okay, clear? D type means data type. As I said that NumPy arrays have a data type, they have a specific data type. Now we'll learn the real magic of NumPy. So I'm putting a time module, and we'll see how much. So let's create an array of 1000 elements. So what we'll do is create or let it be. So we have an array of 10,000 elements. Now we will write two functions. This will calculate the sum of an array. Using normal programming. So for I in n, so for example, sum normal for 1, 2, 3 will be 6. Okay, then we will define something else, and then we will use the numpy feature, numpy.sum. Okay, so we have two functions who do the exact same thing. And now we will try to see which one is faster on our array of 10 million elements. This is an array of 10 million elements. Okay, so start time. I'm using a time function here. This will give me start time. I should actually, you can see it here. Yeah, okay. So I'll use this function again. I will call my sum normal on n. I will print. I will define n time. I will print n time minus start time. This will give us the time in seconds this function took to execute. Okay, clear? Import numpy as np. You have to import it first. And go. So 0. Sorry, this is actually loop only. Why is it returning too many totals? Okay, yeah, now we'll do it. So total is 499.8.008 and it took 1 second. Now we'll use the same piece of code and we'll just do a little bit of replacement. As you can see that it took 0.06 seconds. 0.006 seconds when we use numpy's inbuilt function. NumPy's inbuilt function is 168 times faster. Total equal to 0 is just to initialize it. This is just a function to find the sum of array. That is it. You can write it howsoever you want. This is just to find the sum of an array. As you can see, 168 times faster NumPy is while calculating sum. Let's try to calculate average now. Average we'll just define by length of divided by length of n. Sounds good. And we'll use mean. So This took 0.95 seconds. This took 0.76 seconds. So as you can see, NumPy is 124 times faster. You are saving so much time, your computation is becoming so fast. Just a minute, guys. Just a minute. Yeah, sorry guys, I had a question on my door. Yeah, so NumPy, this is the use of NumPy. Someone was asking me, right? Yeah, Abhinay. So your computations have become faster by magnitude of hundreds. Let's add few more zeros. Okay, this is too big. The computer is not able to compute it at all. But we can do it. Let's just interrupt and kill this. Okay, I've restarted the kernel. I added too many zeros. Anyhow. What you see? It is taking 11 seconds. Then NumPy just took 54. 0.054. So NumPy is around 100 times, 100 to 200 times faster when you are computing using NumPy. It's because NumPy is actually written in fast languages like C, C++, and they have just given us wrappers over Python. So this helps to compute things in a very fast time. One of the main reasons why people use NumPy. Like, I can show you one more thing. Matrix multiplication. Python. So we'll just copy and paste this code of multiplying the matrix. This is a better code. So we'll do the same thing again. We'll define a matrix A as 1000, 100 cross 100, B as again 100 cross 100, and we'll try to multiply A and B. So we have our normal algorithm. and it took around 0.44 seconds. Now we will use our NumPy algorithm. This time the speed up is not very fast. It is just what 3 times faster. But as you increase the number of rows, NumPy becomes very fast. You can see this, it's like taking time. It'll take a few seconds to execute. A lot of seconds actually. You can see that it's not even being able to compute the result because the matrices are so big. It's taking so much time. Or maybe my computer is slow, either of that, but yeah. It should eventually be able to complete and compute all this. There's nothing called NumPy. No, NumPy is used for a lot of other tasks also. These are the main things, mostly for vector addition and vector multiplication. Okay, this is three. So we can see it's taking a lot of time. I will just go ahead and interrupt this. Yeah. And as you can see, NumPy will take a few seconds to multiply two huge matrices of 10,000 plus 10,000. Let's take a smaller matrix. 10,000 plus 100. Let's just restart this for some reason. Yeah. So we have function. As you can see, it's taking a lot of time because it's very slow. To do this with NumPy, it will take a few seconds and we'll be able to execute it. Next time we'll do it with NumPy before we proceed to do it with ordinary Python, but you can try this at home. You can try and do this. You can use different vectors of different size and see how much time does it take for NumPy to compute and how much time does a normal algorithm take to compute. And you will realize how fast NumPy is in these cases. Okay, apparently the matrix is too big to fit in RAM. Anyhow, any questions till now? What we are doing, what we have done? This is the last one discussion. Anybody, any questions? Yes, no, maybe? Yes, you can define whatever vectors you want. No issues. What vector do you want to define? Tell me. I'll show you how to define it. A to Z. So you have to define the data type as object in that case. NumPy is used basically for mathematical calculations, and that's why you keep it either float or int. So you don't define A to Z, but you can. But you mostly keep float or int. Okay, very clear. What makes NumPy so fast? NumPy is fast because the libraries are written in C and C++, which are very fast languages, and it also uses parallel processing to make it fast. So it utilizes the four cores of your CPU and makes parallel processing to do fast computations. I take what any numbers you take. Wait. Let's take any number. Let's take we let's take one. We can define 2D list as a NumPy matrix also, and you can do this. Now will become a NumPy ND array. Okay, sorry. You will see this will take a couple of seconds to multiply, while this had to be stored manually. Let's just interrupt it anyhow. Yeah, as you can see, whatever vector you want, you have created it. As simple as that. If you want random, you can define random. If you want a specific number, you can define a specific number. Anything else? Okay. So one more library is called pandas. Now studying pandas is your homework. Pandas is NumPy is used for mathematical data manipulation, whereas pandas is used to drop, join, more like use data for. So pandas is used more for managing data, and NumPy is used more for playing around with data. It will help you for analysis, modeling. So this is something that you guys have to do yourself. I am using a Mac OS. My company has gracefully given me an Apple computer. But Python works on any OS, and Anaconda will work same for any OS. Don't worry about that. Okay, guys, any other question? Anything you want to ask? Okay, then we'll end the discussion now. I'll post the recording. HackerRank also has a track for NumPy where you can get to practice some NumPy questions. Yeah, you can just filter by NumPy and I can practice questions. There are some 20 questions, 10, 15 questions if I'm not wrong, but they'll help you to learn NumPy in a better manner. NumPy is for data manipulation. Panda is for data visualization. It has to use and analysis. You can build charts and all, graphs and all. You can see correlation and all. NumPy is more for transforming data from one form to another. To make data fit for machine learning, NumPy is used. Yes, that's cool. So I'll end this meeting. If you have any questions, just ping me privately. We'll post the recording and keep practicing. Okay, bye. Good night.